The checkbox, no, it's in the instrument methods. There's a checkbox for APCI and something else. Take it off or no?
Leave it on.
Leave it on, okay.
Leave it on. What that's for is we have this APCI, APPI combo source where we can turn off the APCI voltage and just use light to ionize. Okay. The key is the ion max source is designed to auto-detect what source is on there. Okay. Occasionally it screws up and thinks you have an APCI source when you really have your nanospray on. And the key is your APCI corona discharge, which is what that box is for, is the same circuit that we pump the electrospray with. Okay.
So if you turn that off, it turns off the voltage?
If it detects as APCI. So if it says your electrospray is fine. If it misdetects it,
because usually we jump that circuit to fake it out that we don't have anything plugged in there, and
it should
go into the thing to say nanospray.
Right. Hopefully it should realize it's nanospray.
Yes.
If it misdetects and you have that thing unchecked, it'll turn your voltage off and you'll just drip for. So I just leave it right on. So that way if it misdetects, it works. No negative effects at all.
There's 2 check boxes there.
Yeah, there's
The other one, it should not be on.
APCI corona and it might be APPI source light or something.
But could that hurt anything?
No, not at all.
We usually have it on.
Yeah, there should be there's a little 9-pin connector or so on the right side. You don't use that at all, right?
The 9-pin.
You use the top one.
Yeah, we use the one on the top.
That's your detector for what type of source is on there. The one on the side is for the APPI lamp. Okay.
This is just a heat source?
It's just a lamp. It's a krypton light, and it will actually ionize species by creating molecular ions via 10.6 eV electron. So if you want to do some photo, if you ever want to play around with photo ionization, you can. Okay, now, from an optics point of view, okay, you've got your ion transfer tube, which is removable without breaking vacuum, okay, and that's hopefully will collect a lot of your junk. Are you guys on tight budget or not?
We clean it all the time.
Okay. I just throw them away when they get coated. If not, you can take them out, you can clean them. I've always used 0.1% formic acid isopropanol in a graduated cylinder in the sonicator half an hour. Okay.
You don't use squirt bottles to...
I don't like the plastic that comes with a squirt bottle.
I sort of, yeah, I've always wondered about...
What I do is I just throw them, I just put them in a graduated cylinder, sonicate them for half an hour, and then use the little reamer tool to kind of ream them. Okay.
So you mean like the needle cleaning thing?
Yeah. You know, it may or may not. The question is it cleans here and it cleans here. I don't know if it actually cleans the inside worth of crap.
Unless you do it with a squirt bottle.
Yeah. Okay. For $60, I just toss them. Okay. You know. What I'd be curious to see is if someone takes one that's showing poor performance, cleans it, puts it back in, and shoots the same sample to see if it actually cleans it up or anything. I've never seen anyone say, here's my data before, it was crap, I cleaned it, it looks better.
You always change so many things.
Exactly. So I just toss mine and replace it. Next comes your tube lens. Okay. The tube lens bends ions into the skimmer. Okay.
So they have a certain width coming out and they get...
Well, they come out as a nice tight packet. Okay. But if we look, you'll notice the end of the capillary does not align with the hole in the skimmer. Okay. They're off axis, almost 1/8 of an inch. Okay. So the ions come out and the tube lens actually squeezes them up a bit and puts them into the skimmer. All the neutrals come out and they make a spot. Okay. That spot will kind of go through 3 lifetimes. Okay. If you're cleaning the instrument too often, which with the FT is hard because you don't want to take the thing apart, you end up seeing a brown circle with a hazy inside. That means you're cleaning too often. If you're cleaning at the right frequency, you should see a nice jet black dot that's very well defined. Okay. If half your skimmer is black, that means you're cleaning way not often enough. So the first time you guys, which I recommend about 6 months.
Because we have never done it, and it's been 8 months.
The thing is, you're gonna what I'd actually want you to do is call an engineer in. I'd call an engineer because and just tell them you want to do a cleaning. It's going to take you 3 days.
That's fine, but just start it on Friday.
Okay. Cool.
So is it something that Because I guess we're under contract, so we're not going to extend it.
Are you under service contract still?
I think so.
Best time to do your first cleaning is. Is there going to be any time when you're thinking your students are going to have a downtime?
We can, like I said, I mean, over the weekend's great. We actually pumped it out 24 hours, and we heated the two because we had a power outage.
You have the blanket, right?
Yeah, we put the blanket on, and in 24 hours it was down to vacuum.
Yeah. And then usually I find it takes me about an hour and a half to clean it, and then to pump it down. You pump down overnight, and then maybe 2-3 hours to cool it down, and then push it back in. The biggest key is to have a piece of string.
Yeah, so you can
get the cord through without them bunching up.
Yeah.
Okay. Yeah, I don't think it's much problem at all to clean that thing. Okay.
Because they showed it to me, they're like, here, bend that. It's just too fast.
Yeah, it's a tight. They're adding more. We now have actually added 4 more engineers to the FT. So hopefully, you know.
Who's the Aussie?
What?
There's a guy with Australian accent that came. It was supposed to be for this area.
Vernon Crowthers, maybe?
Yeah, is it Vernon? Yeah. Is he Aussie?
I don't know if he's Aussie or British. We picked him up from, he was an original VG guy, so he's probably UK or Australian, one of those guys. Okay. Q00, okay, is your first quad, okay. Intermultiple lens 0, Q0, intermultiple lens 1, okay. Q1, and then intermultiple lens 1. Now, there is a gate lens, which is also the split lens. There's 2 names for the same thing. Okay, this is your one of your AGC control lenses. Okay, so we'll talk about that later. When I say there's an opening and closing the trap, that's the function. Okay. Hi, I'm Craig. You are.
Hi. Nice to meet you. I'm Juji. Juji.
Juji.
Just think of the fruit.
Juji. Okay.
Make you Lulu.
What?
Lulu.
Lulu.
Yeah.
Okay. Questions on the ion optics? Okay. Okay. Quick thing about the RF poles, okay? Is there somewhere I can write, or just draw on your book. Draw on this page. What is RF? You guys following along in the book?
Yes. The book what? This one?
Yeah. Yeah. Any of these kind of pages is fine. Okay. You can either have an octopole, so draw 8 round rods, 4 that form a diamond, and 4 that form a square. Do you know what I mean? So 8 octopole, draw on your page, 8 round rods, and 4 of them form a square, and the other 4 form a diamond.
Why don't you try that?
Doesn't matter. So on an octopole, you got 4 diamond rods, and 4 that form a square. On a square quad, you've got 2 vertical rods and 2 horizontal rods. So you can see here, there's my square rods, and there's my diamond set. Okay. In the square quad, your horizontals are tied together and your verticals are tied together. So in each object, whether it's an octopole, okay, like the back, or it's a square quad like the front 2. No matter what, you have 2 sets of rods. You either got the horizontal verticals on a square.
So it alternates diamond to square.
Right. Or you have 2 sets of rods which form a square in the diamond pattern on the octopole. No matter what, it's always the next rod is opposite of the previous rod. Okay. What we do is we apply an RF field to those rods. Okay.
It's an oscillating voltage.
It's an oscillating voltage. So what is RF? Okay. It's a voltage which changes polarity relative to a center point, or what's called the DC offset, or the float. Okay. In this picture, I'm showing the DC offset is 0. It is never 0 volts. It's some particular voltage. Okay. So let's take, for example, draw this little picture here. And draw the little picture. Or, if you want. Yep. Yeah, so we're going to label some voltage and do some quick math. Draw a little wave. Okay. I want to put a negative 10 volt DC offset. So you're floating the DC at negative 10 volts. Okay.